Oh, yeah, you got some good ones. Good photos there. Well, hello, everyone. Good afternoon, good evening, good morning, depending on where you are in the world. Welcome to Red Planet Live. I am your host, Ashton Zeth. I'm elated to be hosting the Mars Society's podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. As a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. So thank you everyone for joining today and supporting Red Planet Live. Today, very excited for today's conversation. Dr. Špaček and I have actually had an opportunity to meet before, so I'm excited that we are continuing the conversation from, 9 months ago, however long it was since the last conference. So like I said, today's guest is Dr. Špaček, a prominent astrobiologist and senior research scientist at the Foundation for Applied Molecular Evolution. Dr. Špaček is a molecular biologist, analytical chemist, and organic chemist with a focus on the study of life on Mars and the clouds of Venus. So one of his notable contributions to the search for life in our solar system is the development of ALF, the Agnostic Life Finder, which is a groundbreaking device designed to detect signs of life on Mars. ALF is now supported by NASA Innovative Advanced Concept and is slated to be incorporated into a future Mars mission, which the device employs electric fields to extract charged molecules from mined water ice on the surface of the Martian planet, enabling the analysis and identification of biosignatures. Say that 10 times fast.
Well, you already said it for me, so now we can just chat.
There we go. We're going to jump
Thank you for the introduction.
Of course, and so excited to be chatting with you today. It's great to get to sync with you last week as well, and we kind of talked a little bit about what our conversation was going to look like today. So I'm really excited to learn from you and hear some of the things that we briefly discussed, and excited for everybody to learn those as well. But as usual, before we jump into the conversation, want to make sure that we kick off the episode today with two important Mars Society announcements. The first is that the 2024 International Mars Society Convention is taking place Thursday, August 8th through Sunday, August 11th at the University of Washington in Seattle. I'm excited that it's going to be in my home state this year. I won't have to travel too far. I will have to get over the mountains, but I look forward to seeing you all at the convention this year. And speaking of the annual convention, the Mars Society is calling for abstracts. Presentations for the International Convention are invited. So those that are interested in submitting an abstract, please do that. It's 150 to 300 words, and it can be uploaded to the Mars Society abstract page. You can find that directly on the Mars Society website. Please note that the deadline for submitting abstracts for consideration is Friday, June 28th at 5 p.m. Mountain Time. Okay, those are my two announcements. So let's dive right in. On Red Planet Live, I have a segment called Question of the Day. I say this every time. There's no right or wrong answer. It's just meant to be an icebreaker. I just want to know what your thought is. And so today's question is actually inspired by your dogs. I loved the photos that you submitted to me. So today's question is, what is your favorite pet memory? And I'm sure that's like a hard one to come up with from deep in the memories, but your favorite pet memory.
Right. So these dogs are quite new occurrence. They are rescued from 4 weeks ago. So yeah, they are just awesome. And I don't count as the memories, they're just current reality. Mm-hmm. So now I'm waking up in the middle of the night to let the baby out when I need to be. So that's my current situation. But I don't know, when I was a young teenager, I got iguanas and turtles, the yellow belly sliders, which are native in Florida. And I happened to actually move here when these iguanas and yellow belly sliders, turtles are basically wild animals in here. So I'm meeting with the pets in nature now.
Okay, so what are the names? We've got a photo and I'm going to share it. What are the names of your two dogs? We've got both here.
Yeah, so the brown one is Peach, and the black one is Alf, actually, named after the instrument I'm working on. It's quite boring, or it can be named after that. Let me show you. This guy, right?
Oh yeah.
Alf from the 80s.
Mm-hmm.
So that's the Alf.
That's fun. Well, also, I mean, Alf, agnostic life finder. Is there a connection there?
Well, I think there's a lot of connections. The show Alf was started in 1986. That was when I was born. So, yeah, there. It's just play with words. Also, the original acronym was for alien life form.
Mm-hmm.
So that's what I'm. Now I can say to my boss Steven that I'm working on Alf when I'm playing with my dog. So
there you go. I like it, that play on words there. Okay, so you've got the 2. Do you have plans for any more? You rescued 2. What's stopping you at 2?
No.
What's 3, 4?
It's so much work as it is now. I want to dedicate more time to work actually, and they are very pleasant, but still distraction from everything I do now. So I'm looking forward when they grow up a little bit more, so they can be more hands off.
Mm-hmm.
Yeah.
But I'm sure it's a welcome distraction when you're, working on finding, elements and of life on Martian planets. It's probably a welcome distraction to play with them a little bit.
Definitely.
Excellent. Okay, well, I would say my favorite pet memory, there's so many that come to mind, but a funny one, when I was younger, I used to have, our family dog was a Samoyed or a Samoyed, depending on who you are and how you want to pronounce it. They look like our polar bear. They're all white fur. They're from Siberia. And we had one of those, and Nico loved to jump in the water. And one day at the park, he broke off of his leash and ran straight into the pond. It was murky, full of geese poop. It was so dirty, and he would not come out of the pond. And my mom's ex-husband ended up going into the pond waist deep to pull him out. We made them ride in the trunk on the way home with the back open. It was so dirty. It stunk. It was a mess.
You mean just the dog or even your friends?
Both of them. They were both completely covered. And he's normally a white dog, but he was just like black and green, just covered in moss and dirty water. It was at the time not a lot of fun, but looking back, it was a fun memory. So you treasure those memories, even though they might have been a little dirty and gross at the time. It's funny to look back at them now. Okay. So let's dive right in. We've got a lot of time here and a lot of questions that I want to ask. So reminder to all of those that are tuning in, if you have questions, please submit those in the chat. I'll try to get those sprinkled throughout the conversation. So don't be afraid. Please submit those questions and I'll make sure to get to them. But the first thing I want to start off for our conversation, let's dive right in. Jan, I know that you and other researchers like Steve Benner, who you just mentioned as well, are working together to on this initiative called Alpha Mars, which involves the search for life on the surface of the red planet. Can you tell us about Alpha Mars, what its mission is, its purpose, your involvement, how did it get started, what's the future look like?
Okay, so when I first came to Florida, Steven introduced me to it's a concept for looking for life on other planets. I came for a different project, but I immediately got interested in this one. Mm-hmm. So I tried to proceed with searching for life through normal NASA channels, but unfortunately, sorry, I'm losing you a little bit. Your connection is quite.
Yep, frozen. I see that it's a little glitchy there. It comes right back.
I hope that you can hear me at least.
I can hear you.
Okay. But I realized very soon after starting working on these projects that NASA is actually not looking for life on Mars. Me as a new person in astrobiology, that was a big surprise. I always thought that NASA is looking, of course, for life on Mars, but it's just for the past or signs of past life and stuff like that. And although the astrobiology community in large is convinced that we have likely extant life on Mars, we are still not looking for it. Basically, the Viking missions in the 70s were the last missions to actually look for life on Mars. We had recently a paper by 40 astrobiologists. The paper was in Nature Communications, and it showed that the instruments we have currently on Mars would miss life, which we know that it lives in Atacama Desert. It's in some regions, which means that currently we don't have tools and don't even plan to send tools to look for life on Mars. And yeah, NASA astrobiology community knows about it. The recent decadal survey acknowledged that fact, so it's not a secret. But although people are urging to do something about it, nobody is actually doing anything about it, because we have quite short time window, and given NASA budgets and standard procedure how you do things, from mission conceiving the mission to execution, it usually takes like 20 years. So there are no pathways how to find life on Mars. I mean, extend life on Mars before we send humans there existing, and there is no clear pathway how to get there. So I try to push people in NASA astrobiology to change stuff about it, but that seemed to be quite hard. So instead, I decided to not wait for NASA to change their mind. Maybe I hope that there will be a strong push to change the approach. I think things are starting to change right now, but it will take maybe quite a long time before NASA is fully committed and acknowledges that finding life on Mars before we send humans to Mars is quite important. So, and that's why I started Alpha Mars project. And then to make it official, I asked my students to help me, or student volunteers to help me start a non-profit organization to make it official. So now we have non-profit organization called Agnostic Life Finding Association. So that's the long story.
There's a lot to unpack there, which brings up, of course, a couple questions. The first one that I want to start with, specifically about Alpha Mars. I noticed that in the mission statement, it specifically says, discover if there is life on Mars before human arrival. Why is it critical that it's before human arrival?
Right. So, as you know, in Mars society, humans are actually planning to go to Mars. And so if you go to a different planet, it's a good idea from sci-fi to know if there's a life there, if that life can somehow affect you, or you can affect that life. From my perspective, I'm quite convinced that there is a quite frequent, we are certain that there is a frequent exchange of material. So I have a Martian rock right here. So we know that we have Martian rocks flying to Earth, and from Earth are ejected and fly to Mars quite frequently. Some of them can carry bacteria. So I believe that there is communication between Earth and Mars, but which means that the life on Mars should not be that dangerous to life on Earth, and vice versa. But the problem is that once you introduce humans to Mars, they will carry with them a large bioload. It's a known fact that you cannot prevent. If you send humans to Mars, you will definitely bring a lot of bacteria. So you might contaminate your samples you are going to collect. So in future, it will be harder to decide whether what you found was actually Martian life or not. it might be harder. It will not be impossible, because once we can sequence the genomes, for example, we can tell the differences. But it's going to be, it might be harder to find Martian life if there's quite a lot of contamination from Earth. So that's one concern. And of course, the black swan event of actual harmful contamination back and forth. In summary, I think we should go to Mars. We should explore Mars with humans there. I myself would go and explore, but we should prepare before going there. Like, we should not go blindly.
Of course, agreed. You mentioned that yourself and other astrobiologists know that NASA is not working on right now trying to identify and find that life. Why do you think that is? Why do you say that they're not looking for it?
Well, that's a very interesting question. Well, I think there's quite a lot of politics. You have limited resources in NASA, and those resources goes to whoever is best in politicking. There could be Stephen Banner, my boss here in Foundation for Applied Molecular Evolution, believes that there is this fear that when we sent Viking missions, which were the results they brought were interpreted as negative results, it basically stopped Mars research on ground for a long time.
Yeah.
There could be something about that. So it could be because of the fear that providing quite a high confidence result that Mars is actually sterile, it might be detrimental to Mars exploration. But I believe that now it's more about that people who have power in NASA astrobiology have different targets they want to explore. So they are more inclined to support exploration of Enceladus and exploration of outer solar system. And as you know, we had already 2 large rovers on the Mars. So now it's time to explore different targets. So I think there's quite a fight. But it's important to recognize that Mars is only astrobiological target, which will be affected by humans' presence in the next decades. So I would suggest that the other targets can wait, right? Because in a couple decades from now, when we are ready or maybe centuries from now, when we are ready to send humans to Enceladus, by that time we will have much more sophisticated probes to analyze life there, whereas we have only very short period of time to explore Martian life, extant life close to surface. So that's why.
Absolutely. Okay. So speaking of finding life on Mars, sending humans to Mars, we talked a little bit, and we're seeing stuff in the news, reading articles online about the Mars sample return. I know you were at, obviously, the convention last year, and we heard from NASA Deputy Director Administrator Tiffany Morgan about the Mars sample return. And we saw in an article today that may be delayed a little bit longer than it originally anticipated. Can you talk us through that? Why could it potentially be delayed? What does that mean for humans to Mars?
Right. So, this mission is delayed because it was very complex. The complexity is basically what killed the missions. So after a review, they decided that it's not feasible to conduct it with the current budgets. And so the current estimate is that if we continued with this program, which was proposed to return the samples that Perseverance is currently collecting, it would be in close to year 2040. By that time, we might have humans on Mars already. So that would be very irrelevant to search for life or making some decisions about, you already have humans there, so they might as well just pocket some rocks and bring them with them instead of sending the rover there. Second thing, from perspective of astrobiology, the Jezero crater, where the Perseverance is collecting the samples, it's great for analysis of past life because it's searching in a old lake delta system where you have deposits of clay in which you have organic material, might have organic material still preserved. So these samples can tell us something if there was ancient life on Mars. But now we see that it's very likely one of the less hospitable places on Mars. It's astrobiologists now assume that there are several refugia where life can actually be. One of them is mid-latitude ice, which is target for ALF as well. You have like salts and caves, but the surface, 3 billion year old dry rock is not the place where you would expect to have any extant life on Mars. So, yep.
So talk us through what information we have so far. So obviously those Mars sample returns, we are anxiously awaiting an update on what that looks like. But from the research and the information that we have so far, you said maybe the rock is not the most hospitable place, but there are other places like in the subsurface ice. I remember hearing at the convention, potentially lava tubes. Like, are there other potential locations where life could be? Can you talk us through that?
Right. So yeah, you name most of them. Basically, it's the mid-latitude ice. Then it could be ice which is closer to the poles of Mars, where it could be deposited in that ice. It could be very likely if the life ever was on Mars, it would be in the deep underground, where we still expect to have some geothermal heating up. And if you have water seeping down, as we know, there is plenty of water on Mars, except it's frozen. So same life we have on Earth, living a couple miles below the surface, can basically live on Mars without knowing if the surface has atmosphere or not, because if you are a couple of miles underground, it doesn't matter much. So those are, and of course the caves. So those are the 4, 5 refugia where we can expect to find life. The surface, close subsurface ice is one of the most accessible places. And actually, what's not being talked much about is that Chinese space agency is actually going to sample that Martian subsurface ice, where we actually expect more chance of finding the extant life. So maybe China might be the first to find Martian life, and that would be very interesting. I think that would kick NASA into higher gear. That would be a sort of like Sputnik event for NASA, and might realize that we are losing this space race in here.
100%, I agree with you. We in last month's episode with Leonard David, that we talked about that specifically, the new space race, with China, just like with Russia during the Cold War. Now it's with China and getting back to Mars, back to the moon, and then to Mars. So we've talked about potential life on Mars. What about life in other areas like Venus? You mentioned Enceladus, Europa, Titan. What is the prospects for life there?
So as you know, I have an association with Venus, with the now the project is called Morning Star missions. It's the first mission is it's a first private mission organized by Rocket Lab, and it was originally there you go. It was originally sponsored by Breakthrough Foundation. The leading person is Sarah Seeger on this mission, and I got to participate on this mission by talking to Pete Klupar. I tried to get some funding from Search for Life on Mars from Pete Klupar. So I explained to him ALF, and he explained to me that the Breakthrough Foundation is currently not interested in Mars, but they are working on a Venus project. So he gave me funding for one summer. I accepted the funding, and starting to wonder what organic chemistry could be in a concentrated sulfuric acid. To be honest, I came to that project quite skeptical. Sarah Seeger and her colleague Janusz Petkovsky presented quite, to me, it sounded quite sci-fi, that you can have life, bacteria, basically in the clouds of Venus. Me, as molecular biologist, I know that in concentrated sulfuric acid, you cannot have life as we know it. It was quite ridiculous to me. I thought that any interesting organic chemistry would be completely destroyed in the concentrated sulfuric acid. But the research I've done in summer 2021 or 2021, I think, I realized that you can have quite interesting, complex organic chemistry. I spent the summer researching that and writing a first paper about that. And now I'm quite convinced that sulfuric acid might be another potential solvent for life. So I'm not sure still about the Venus, because there are big problems. You can have the interesting organic chemistry only in the clouds of Venus.
Mm-hmm.
But if you are in a cloud, everything is falling down. And if you fall below the cloud, you get to temperatures which are over 400 degrees Celsius. So you are destroying all organic molecules in those temperatures. So the life on Venus would have to figure out how to stay in the upper portion of the clouds of the sulfuric acid. So in there, I was very skeptical. Now I think maybe, but still maybe rather not. Maybe on some planets with sulfuric acid oceans, where you have you turn bedrock to sulfate deposits, and then you have shallow sulfuric acid oceans. That could be interesting alien life forms. And regarding Enceladus, I'm actually and other outer moons like Europa. We are working on an above and below project right now, which was NASA ICAR project now at UF. Yeah, there could be life because, as I said before, I believe that there is exchange of material between planets in the solar system. So if you have a life on Earth or in ancient Mars, you eject that life and it can get itself deposited into different oceans that it can be there. So I would not be surprised if it's there, but let's find it after we decide whether Mars surface has life.
Right. Let's start with one at a time. Yeah, thinking of, life on other planets, I was curious. We see sci-fi movies. There's been a few in the last, I think, year. I think one of them was called Don't Look Up on Netflix.
Yep.
And that was really popular with Leonardo DiCaprio. And one of the themes was that, like, the scientists have been warning us that something like this could happen, and nobody listened to them. So putting on your science hat, how do you think people would react? Say NASA says tomorrow, hey, we found life on Mars. How do you think people are going to react?
Well, it depends on the people, right? Some people would be like, yeah, we expected that. It would be, I don't know if it makes an interesting title, like we found life on Mars. But if you explain that, yeah, it's a bacteria that has generation time, it replicates once per one century, and it's a very resilient extremophile which would not survive above freezing temperatures. I think a lot of people would lose interest. Like, how many people are interested in life in dry Antarctic valleys? So for some people, that would be interesting factoid to learn about. For me, it would be like idea that you can have life on different planets. That's very exciting. So as stars age, their habitable zone is expanding. So right now, life on Mars or in different solar systems in similar situations. So Mars can be basically waiting for sun to expand for the habitable zone to expand more. And so in next billion years, Mars can be the habitable planet in our solar system. It might not be the Earth. So, and it would be very interesting to find if a Martian life is a separate origin or if it came from Earth. And if it came from Earth, we know that life can travel between planets. And the question is, can it travel between solar systems? And if it can, then life is everywhere. So, and then the big question is, so why we don't see civilizations everywhere? Do they kill themselves somehow?
Yeah. Did they kill themselves? Was there, an impact of, I mean, you're a comment of some sort, that like with
I'm
killing the dinosaurs.
Yeah, I'm going to be, I believe it's a dark forest hypothesis. Have you read Free Body Problem?
I've heard of it. I have not read it, admittedly.
So Free Body Problem is, well, dark forest hypothesis is that life actually, well, civilizations want to kill each other. So it's better to, when you see a civilization, it's better to make a first strike and while the civilization is still young, because on cosmic scales, if you look back, our civilization 100 year ago was basically very primitive. Now within 100 years, we developed into this. Who knows what we can do in the next 100 years? Maybe it will be spread over our solar system. So civilizations can exponentially increase in complexity. So it's better to kill them off while they are young, right?
Well, that makes you optimistic about searching for life in the universe, doesn't it?
Yep. But it's better to know about these things. I'm sure that other people are more optimistic, but it's better to know, better to keep all of these possibilities in mind.
Absolutely. Okay. Well, I'm going to keep that answer in my back pocket. I was just traveling for work and I got stopped in the airport, and that was something we talked about. So next time I get asked that question, I'll have an answer for them. I like yours better. But I see we do have a question. I want to take this one first, since we're on the topic, and it says, but what if life on Earth came from Mars? That would make us Martians.
Cool. Then we are Martians.
Hey, there we go.
Yeah, again, for some people that will barely change anything. That again, like it doesn't change your life in general. It changes your, little bit of philosophy. I don't. Maybe some people will just decide not to believe that, right? Some people believe that there's no evolution still, even though that's we are quite certain about it. So similarly, I don't think that some people will believe, even if you present that evidence that happens. So there is going to be definitely a spectrum. Some people might be interested. For me, it's quite interesting, but I don't know. I like to know these things, but
I think some people are going to be highly disappointed. They're anticipating the image of extraterrestrial life. They think it's the green alien, and it's coming to attack us. So if NASA did say, hey, we found life and it's microbial life and it's under the surface, and like you said, its lifespan is one evolution, then it really doesn't mean much to them and in their imagination of what extraterrestrial life is.
So yeah, this is quite like off-putting for me saying these things. Well, I'm personally very interested, right? I'm spending my evenings researching this, but I'm just guessing that other people would not be as excited about that as I am. Well, I assume that your audience would be quite interested. So
yeah, I think most of the listeners here would definitely be excited about it. Okay, well, I want to shift gears a little bit. In anticipation and preparation for our conversation, was doing some research, and I saw that you wrote an article earlier this year called "Radiation on Mars is Less Likely to Kill You Than Sitting on Your Couch." Can you explain that to us?
Yeah, so that was for Primordial Scoop, which is a blog where mostly me and Stephen Benner contribute our ideas to. NASA keeps, well, this is not a new idea, right? For people in Mars Society, we know about Robert Zubrin's discussions that if you tell the astronauts to stop smoking on their way to Mars, they will develop less cancer than if they kept smoking, right? So I actually made a mini review of the literature, and I found very interesting fact that there are places on Earth, like the city Ramsar in Iran, where you have background radiation higher than is on surface of Mars, and you have people living there for generations without any visible detriment to their health. They're having babies there and they are fine. So I don't think that the radiation on Mars is the biggest problem. I think the absence of atmosphere and cold is the bigger problem. Maybe the lack of gravitation might be bigger problem, but radiation, I don't think it's that problematic.
I like it. Okay. Well, speaking of Primordial Scoop, I was again looking at some of the articles you wrote, and this does go back to the Mars sample return. But regarding the Mars sample return, you predicted in 2022 that the delay of the sample return was likely to happen. Walk us through that. How do you know that was going to happen? What signs or keys were you given ahead of time that you knew this was coming?
So, yeah, the mission itself is very complex, and actually, other people were talking about it as well. I was not first. I was first to make that joke that you can save 12 billion by asking SpaceX and Chinese space agency to just collect the samples that Perseverance is putting in there. So yeah, the mission, as suggested, was very complex, and I'm not surprised that it was basically shut down yesterday by NASA. Now they are looking for ideas how to return the samples cheaper than 14 billion. Interestingly enough, in next decade, it might be even harder to find financing for NASA, as U.S. budget will be mostly paying back the interest on the debt U.S. government have. So there might be even less funding for NASA to come. So that's why I think it's important to engage private organizations, not rely on NASA with everything, and that's what we are trying. The Venus mission, which we discussed, is an example of a first private interplanetary mission. So if that was actually inspiration why I decided to start Mars, Alpha Mars. I believe that we can find life on Mars, even if NASA does not get into fully supporting this idea.
Yeah, absolutely. No, I agree with you there. I think, I've had the opportunity to speak with a lot of people, those that are from NASA, outside of NASA, private industry, commercial, and we all seem to have a general consensus that the privatization and commercial space industry is good for everyone as a whole. So obviously you talked about, your connection with for Alpha Mars, and you're trying to go that direction. Is there anything else that's on the radar specifically for private commercial? How do you see that potentially helping Alpha Mars or astrobiology as a whole, utilizing its relationship with the private and commercial space industry?
Well, I think that both sides need to realize that they exist, right? Astrobiologists that are used to just go with every mission just through NASA need to realize that NASA might not be the only way how to send your instruments to Mars. It might be cheaper to ask Rocket Lab to send your probe to Mars or Venus, or ask SpaceX, right? So that's one way. And from the other side, I think that SpaceX, if they plan to send humans to Mars, they definitely need to research their future landing sites. So the collaboration from the other side, asking scientists, including astrobiologists, to prospect their future landing sites that might be mutually beneficial. So I'm trying to make this connection more obvious and trying to use this connection. So that's the idea.
Is there a particular company that you're aligning with that has similar objectives that align with astrobiology? Like we see that, SpaceX is becoming the partner for NASA for launching of its crew, both its own SpaceX astronauts, but NASA astronauts. We see, Axiom is working on building a new space station. We see these space companies are coming into the market and they have a specific niche, a product, something that they're working on. Is there a particular company that aligns more with astrobiology, maybe some of your objectives and the things that you're trying to research?
Well, I think it's right now there are not many rocket companies that have functional rockets.
Fair, true, good point. Yeah,
we are fully private, right? You have Rocket Lab. Peter Beck is very much interested in life in space.
Yeah,
but Rocket Lab is quite small company right now. I think the Venus mission. Maybe we can convince Peter Beck to send for us one mission to Mars. But I think going forward, SpaceX, if they can deliver hundreds of tons of instrumentation on Mars for much cheaper. Right now, if you book a Falcon Heavy, you can send 17 metric tons to Mars for 100 million, which is it's surprisingly cheap compared to standard NASA delivery systems. So that's something to think about.
So at this point, it's just the big players, and that's SpaceX at this point for getting payload.
To be honest, I'm not expert on this, so there might be others. I'm sure that there are plenty of companies starting in China, half private, half state-owned, as they must be in China. But I'm not aware of any other private company. Blue Origin might be getting there, but they are not there yet. They still have problems with their engines. So I think that currently that's it.
That's the start. Well, something that you had mentioned to me when we had a chance to connect offline, and I'm hoping that you can share with listeners, is about the Impress project. Can you talk about that?
Right. So ALF mission, I will get to Impress in a second. ALF mission aims to use actually in situ resource utilization, which means that when you want to send humans to Mars and return them alive, you better do some mining of local Martian resources, which is carbon dioxide and water, in a form of water ice underground. And then you can use several chemical reactions to produce methane and oxygen as a fuel and propellant to get back off the surface. And of course, you can use the water for your astronauts as well. The problem is that some missions, like JPL's in the NASA official mission to Mars, which Bill Nelson, NASA administrator, said that is going to fly before year 2040, deliver humans to Mars. They plan to bring the fuel with them, or bring the propellant. Fuel is just the reduced carbon, and propellant, or the reduced component. Oxidizer is the second one. Together they are propellant. Anyway, so because you have missions that plan actually not to do in situ resource utilization, there might be a scenario where nobody is mining Martian ice, so we would not be able to use our ALF instrument in time. So that's why I started working on a different mission, which is a ride-share mission, where the idea is that you book actually Falcon Heavy rocket. You fill it with payload from astrobiologists all over the world and other scientists. You send it off to Mars and deliver different instruments. The difference is that instead of sending large landers like Perseverance or other big landers, which then aim to drill underground, you send straight planetary penetrators, which are small pointy probes, which basically embed themselves in Mars upon impact. So they don't need a parachute, maybe just a heat shield, and it's a much less complex mission, much cheaper way how to deliver samples, how to deliver your instruments. So I'm now writing the white paper. I'm soon going to invite more scientists to help me writing it, and then we will get it out and try to get the payload going. Actually, to fund this mission, I want to include, if we have problem to fill the 100 metric tons of the Falcon Heavy payload, we can invite people to provide art pieces which they want to deliver to Mars. So, and it would be for a price of $1,000 per 100 grams. So if you want to deliver 100 grams of something on Mars, you just pay $1,000 and you can have it delivered. And I think there could be large enough market. Only caveat is that it needs to be sterilized. So for the art pieces, it will be just all heat sterilized before loading and sending off to Mars. So I think every school can afford to send at least thermometer or seismometer to Mars for that price. So that's what I'm hoping for. And yeah, somebody commented lithosphere braking, and that's exactly it. So instead of aero braking, you are braking in the lithosphere, and with penetrators you can have accelerations like 30,000 Gs depending on the exact trajectory. So many instruments can survive that, and you can make penetrations under the ground up to like 50 meters instead of sending big landers which drill just 2 meters below the ground for billions of dollars. You are doing the same research much cheaper. And there you go. That's the summary by Lawrence showing some of the penetrators. And actually the F, it's a penetrator called Deep Space 2, sent in 1996 by NASA. It was 2 penetrators with some seismometers, and which were supposed to be delivered to Mars. Unfortunately, they lost signal after impact, but many penetrators were already designed. The problem is that they are designed to be always ride sharing, and they have and nobody to share the ride with now. So I want to bring everybody together. And now you are sharing an image of ALF. That's the stack of the. Should I describe how ALF works? Since you have it up here?
Yeah. Let's do that.
Okay. So ALF, the agnostic life finder, is based on electrodialysis. It's a process where some molecules can migrate in electric field. If they have a positive charge, they move towards negative electrodes, and vice versa. So if you have a stream of water, you can separate positively and negatively charged ions, and then you can have membranes that have different sizes of the pores, and then you select for what we are selecting for is large polycharged molecules. So for polymers, which contain multiple charges on the surface and can pass through small pores, which means that we are selecting for mostly biopolymers. There are very few linear polymers in nature which are made through geological processes. So if we find a polymer which have a repeated units, it's very likely biologically produced. Something like DNA, which is negatively charged. Martians, if they started as a separate started as a new tree of life, they might have a different kind of backbone of the in their genetic polymers. But what all life has to have is some molecule which stores genetic information, which can be copied, well, not precisely, but have some mistakes in it, and those mistakes can be replicated in next generations. So that's how you make evolutions. Most of the mutations are harmful for you. Some of the mutations, however, increases your fitness, and that's how you can make up to us, right? Starting from simple self-replicating RNA molecules. So if we find polymers which are charged, then we likely found life. So what you shown there was the instruments that my students are assembling.
Yeah.
I have some previous students. That's Kate holding the previous. And here.
Oh, the one behind you. The one behind you.
Yeah, I was showing here. That's Kate Sheldon from Princeton University. Here I have Victor and Daisy, who are working on the Venus project. Actually, Gage is here hiding behind the poster on the Venus projects. And current president of Alpha Mars is here. It's Chris Temby. So those are my students. Yeah, so now we are working on that. Some of the students are volunteering. Actually, I called for interns for the Mars project. Some of them got funding, and the rest of them decided to stick around, even if they are not funded. They're just volunteering their time to build that. So that's great. I'm very grateful for their work.
Yeah, and you seem to light up talking about them, so that's pretty cool. Let's see. I think we've got one or two others. So this is your students again.
Yep.
And are they working on Alpha as well?
Yep, they are assembling the stack. So in the blue shirt we have Holden, we have Josh, and we have Elijah putting together the stack. Right now it's a very early stage of breadboard, trying to separate simple polyelectrolytes from a stream of water on a tabletop. During the NIAC project, that's the NASA Innovative Advanced Concept, we were awarded. We promised that we are going to deliver benchtop prototype capable of separating polyelectrolytes from the stream of water. We already know that it works in a stationary ALF, where you are not making flow through, you just put the liquid in and then separate it. Now we just need to make it in a stream, so continuous separation.
I see we've got a question about ALF, and so let's get to that. It's could ALF also be used on a Venus descent probe?
Yeah, unfortunately there will not be enough time, enough payload, and the sulfuric acid would destroy everything. So, yeah, working with sulfuric acid, it's very problematic. Everything we have here on Earth, all organic chemistry we used for plastics and so on, it's quite unstable in concentrated sulfuric acid. So those delicate membranes with exactly defined pore sizes would be destroyed. Not to mention that electrolysis in a concentrated sulfuric acid would be very problematic itself. So no, also there will be not enough liquid collected for that. Actually, the descending probe is a fluorescence nephelometer, so it shoots laser and observes return light. If it's just reflected light or refracted light from the droplets, then it tells us about the droplets. But if it's fluorescence, it tells us that there's organic chemistry. That was one interesting thing we found in my lab, that organics when you put them in concentrated sulfuric acid, they usually turn to fluorescent molecules. So that was a very surprising finding, but it's very helpful for our autofluorescence nephelometer. So if there's organic chemistry in Venus clouds, it's going to be fluorescent, likely.
Interesting. All right, that's promising. I like it. I see we've got one question here, and we've touched on it a little bit, but I want to be able to read this question from our audience member, and it's, will we find life on Mars before we send people there who can drill kilometers into the ground where there might still be liquid water?
I don't think we'll be able to drill kilometers into the ground before we have humans there. I think the deep drilling, it's a harder problem than sending humans to Mars surface. So I think if we're going to drill deep, you will send, who was that in Armageddon, drilling the asteroids? You will send a crew of people to actually do that drilling, right?
Okay, I see we've got one more here, and I'm going to show this question, and maybe you can help me with this one. So even if just microbial life would impact us all because of genetic similarities and or differences, do they use DNA, RNA, or something completely different?
Right, that's something we don't know. If the life is, oh yeah, Bruce Willis. Yeah. Bruce Willis was the guy drilling the asteroid. Anyway, yeah, if the life on Mars is related to us, if we are Martians or Martians came from Earth, then they are going to be using DNA RNA system. If they emerged on Mars, they might have accidentally evolved RNA as well, because the conditions were similar to what we have on Earth, right? They were quite similar 4 billion years ago. You have comparable geology and liquid on the surface, liquid water. So, and what would they impact us? Yeah, I don't know. They would very likely not be able to infect us because parasitic like infections, you have to co-involve with your host. And since there are no large mammals on Mars, as we know of, it's very unlikely that they would be able to affect us directly. They might be able to affect us indirectly because they might be very efficiently adapt to survive in permafrost. So my scenario, doomsday scenario of a red plague, is not that they're going to infect all humans, is that they are going to get into permafrost and eat all the methane deposits and release them, causing massive global warming. But it will take a couple of centuries because slow replication times in the permafrost, or maybe thousands of years. But yeah, we might now start something which will be affecting humans or Martians in a 1,000 years to come. So I think we should really consider our next steps.
I love your optimism. Well, let's see. I know we're coming up on our hour already. It goes by so fast. Any other projects? Any other cool things that you're working on? Any initiatives? What else you got going on that you want to leave everybody with?
I think the Venus and Mars are plenty. I now started the reconstructions of my house, so that with the dogs and the new garden. That's quite a lot.
What are you planting in your garden?
So I had mom visiting, and she planted a bunch of tomatoes, and now it's mostly like preventing dogs from eating everything my mom planted in.
Oh, so no vegetables or anything that's gonna last after the dogs get through there.
Yeah, and they are scourge on that.
It's tough. They want to get into everything. Well, hopefully, like you said, they'll grow up a little bit and be a little bit more independent and not get into everything.
Yeah, I need to get moonflowers.
Moonflowers. There you go. Well, I can't believe it's already been an hour. I told you it would fly by. I'm so appreciative. Thank you so much for your time today and joining me and answering all of my questions and the audience questions. I know that I'm walking away. I've learned something. I'm going to take that to my next conversation that I have with someone when I'm walking through the airport and they ask me some science and space questions. So again, thank you so much. I appreciate you being here today.
Yeah, thank you for inviting me, and it was fun. It was nice talking to you. Thanks.
Of course. And thank you everybody for tuning in. I appreciate all of your engagement, your participation. I love it when you guys sent some questions. We're going to close out for today. Thank you everybody. And as I always say, the best is yet to come.